Okay, naming ionic compounds. So the first thing we have to be able to do is identify that the compound is ionic. We identify that it's ionic, and then we can use the ionic rules. So how do you identify it as an ionic compound? Well, the most straightforward way is to look for a metal and a nonmetal. So you're going to have a metal and one or more nonmetals. And then you can assume that the compound is ionic. Ionic compounds, we break everything into categories. And I know that probably seems annoying to you, but it's necessary. So ionic compounds contain a metal and a nonmetal. And within that group, we have two different categories. One in which the metal forms only one type of ion, and those are the sorts of metals that we've talked about so far. Group 1, 2, and 3. Did we talk about zinc and silver yet? I don't think so. Anyway, group 1, 2, and 3 for now. And then we have the other metals. They can form more than one kind of ion. So type 1 forms one kind of ion. These are group 1A, 2A, group 3A. There are other elements in group 3A, gallium, indium, and I forget what TL is. We're just not even going to run into those, but we can just remember group 1, 2, and 3. Aluminum is in group 3. Then we've got zinc and silver. Zinc and silver are a couple of little exceptions. Let's see, do we have a periodic table coming up? No, that would be too convenient. I'll have to draw one. That'll be beautiful. Okay, let's see, we just need a little piece of the periodic table here. So just use your imaginations there. Okay, so this is aluminum. This is group 3A. So aluminum is 3+, and now I imagine in my chemistry land that we're going down the stairs. And down one step to the left is zinc. Zinc forms a 2+ charge. Aluminum's 3+. Probably should have done those in different colors. So here we've got 3+, because it's in group 3A. Then we go down one step, that's 2+. We go down another step, and we get to silver, and silver is +1. So there's a pattern for you. 3, 2, 1. Stair steps. 3, 2, 1. So zinc and silver also only form one kind of ion. It is not really related to their group numbers. It's just something you remember. All the other metals form more than one ion. And so we call those type 2 metals. They form 2 or more different kinds of ions. Those are transition metals for the most part. One's in the middle here of the periodic table. But they are also things like tin and lead and bismuth that are over here, not in group 3A. They're technically not transition elements, but they're not in group 1, 2, 3, zinc or silver. So they're in the other group. So we've got two groups of metals. What am I doing? I don't even know what I'm doing here. Okay, so group 1, type 1, this is groups 1A, 2A, 3A, zinc, and silver. Psst, silver. The type 2 metals, everything else. Okay, two groups. 1, 2, 3, zinc and silver. Everything else. So these are the metals whose charges are predictable. And we see that lithium, it's in group 1, +1 charge. Magnesium in group 2, +2 charge. Aluminum +3 charge, it's in group 3A. Zinc and silver, you just have to remember those guys. Then we have the others. So here are some of the common other ones. So chromium. Chromium forms 2 different ions, +2 and +3. And there is no predicting this from the periodic table. Iron forms 2. Cobalt forms 2. You're like, oh, well, there's a pattern here, 2 and 3, 2 and 3, 2 and 3. Yeah, but here's copper, and he's 1 and 2. And then there's tin, he's 2 and 4. And then there's mercury, and he's even stranger, and we're not going to talk about him very much. And then there's lead, 2 and 4. Okay, so these other guys are going to form more than one kind of ion, and you can't predict them from the periodic table. So if we say iron ion, how do we know which one? Well, we have to add something to the name. And so we use Roman numerals. So that's what these numerals are here. Roman numerals. This is the Roman numeral 2. So chromium 2 is chromium with a 2 plus charge. Chromium 3 is chromium with a 3 plus charge. So the Roman numeral tells us the charge on the ion. And that's how we know what the charge is from the name. There is also this older system of naming, which I'll tell you about, but we're not going to use. Okay? But you may see it occasionally, and so I want you to at least know what it is. They used to use a suffix, us and ik. And they would name the lower charge was us and the higher charge was ik. So you have chromous and chromic, ferrous and ferric, cobaltous and cobaltic, etc. But that didn't tell you the charge. It just told you the lower and the higher. And you had to remember that lead was +2 and +4, not +2 and +3. So that's an older system. It is still used somewhat. You see toothpaste commercials, and our toothpaste has stannous fluoride. Stannous. Well, stannous is tin. It's tin too. Do you know there's tin in your toothpaste? Yeah, but it's tin 2 ion, and it's not like there's flakes of tin metal in your toothpaste. That wouldn't be good. So when we name these compounds, we're first going to look at binary ionic compounds, where we just have 2 elements. That's what binary means, 2. 2 different elements. And so to name a compound like this, we just name the metal first, and then we name the nonmetal. Now, just like in traditional marriage, the woman changes her last name, right? When we put a metal, which is masculine in chemistry land, with a nonmetal, which is feminine in chemistry land, the woman changes the ending of her name. And so if we had chlorine, it would become chloride, because they got married, right? They're together now. We don't specify the charge of the metal, talking about the type 1, because we know what the charge is from the periodic table. Let's do some examples. What's the name for NaCl? Well, we have to identify the 2 ions that are present. Here we have sodium ion, and here we have a chlorine ion. There's 2. So it's going to have 2 names, one for the metal, one for the nonmetal. The name of the metal is sodium, and then chlorine, because they got together, is going to change the ending of her name. So chlorine, we change the ending to "ide," and this becomes chloride. So the name for NaCl is sodium chloride. Because. Yeah. Why does it change to the "ide"? Because that's what we decided. Yeah. It's like I can make up reasons if you want reasons. So if we just called it sodium chlorine, then that might be confused with a list of elements, right? And so sodium chloride, we'll find as a general pattern that the second word is related to an element's name, but it's not exactly the same as the element name. And that kind of clues us in, this is a compound. These guys are together. Most compounds have names with 2 words, just like most people go by a first name and a last name. There are some that also use their middle name, or they have a hyphenated last name or something, so there are exceptions, but generally 2 words. So here's an example of these common anions, and we've learned to predict their charges from the periodic table already, but this is just showing you what happens to their names. Fluorine, and remember there's no flour in fluorine, F-L-O-U-R, use that to make cookies. That's not in chemistry. It's UO. Fluorine, symbol is F-. This is the base name, and we change the ending to "ide," we get fluoride. So fluoride, chloride, bromide, iodide, oxide, So sometimes we take off just the last part, and sometimes now here we've taken off 2 syllables. Oxygenide would sound really funny, I think, so you'll get familiar with these. Sulfur becomes sulfide, nitrogen becomes nitride, again, because nitrogide, that's silly. So those are what happens with their names. And I will not try to trick you on an exam with their names, okay? So chlorine, chloride, those could be 2 choices. But like with oxygen, I wouldn't put oxide and oxygenide and try to trick you to see if you remembered, oh, we have to get rid of 2 syllables. But you do need to remember that the ending changes to "ide." So let's do an example. Name the compound KBr. Well, we're going to practice identifying these, even though we know right now, because this is the first group, that these are all metal, ionic compounds. Always look at the first element and ask yourself, what kind of an element is that? Find it on the periodic table. It's a metal. If it's a metal, ding, 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 it's ionic. End of story. Don't have to think about anything else. So we've got potassium, and that is one of those type 1 metals, group 1, 2, 3, zinc or silver. And so its name is just potassium. And do your best to spell these things correctly. Potassium, the other element is bromine. But they got married here. They became a unit, so bromine becomes bromide. So we leave a space, and it's bromide. These are not proper names so that we don't capitalize them. Any questions? 2 ions, name the first one, name the second one, and change the ending of her name. Let's do Zn3 and 2. Well, Zn, what kind of element? Metal or non-metal? Metal. Is it in group 1, 2, 3, zinc or silver? Yeah, it's zinc and silver. So it doesn't need a Roman numeral. And so we just write the element name, zinc. And the other element is nitrogen. She's a girl. She's going to change her name. Nitrogen becomes nitride. So this is zinc nitride. We don't need to do anything with those subscripts because the charges tell us how to do that. Yes, question? They don't get put together. There's a space between the names. There's a space. Just like when you write your name. I write my name, Jody Kawagoa. I leave a space between my names. Any other questions? Type 2 binary compounds. These are the other metals, the ones that do form more than one ion. Here, we need to specify the metal's name. So we're going to use Roman numerals. No, I don't do that. Okay, so just in case you're a little rusty on your Roman numerals. The number 1 is a capital I. Number 2 is 2 capital I's. The number 3 is 3 capital I's. And then I think they realized, okay, this is going to get tedious. This is just tally marks. Okay, so 5 is a capital V. 4 is 1 less than 5. So it's an I before a V. 6 is 1 more than 5. So it's 1 after the V. 7 is 2 more than 5, so it's 2 after the V. Aren't you glad you don't have to do multiplication with Roman numerals? Yeah, they used an abacus to do that. One of these days I'm actually going to learn how to use those, but I don't know how. I don't think we'll go any farther than we probably won't go past 4, but you need to know what the Roman numerals mean. So we use those to tell the charge of the ion, not the number of them in the formula, the charge. And it's always in parentheses. So, for example, we've got these 2 ions, Cu with a +1 charge and Cu with a 2+ charge. So this one, +1 charge, is copper with a Roman numeral 1 in parentheses. There is no space between the word copper and the Roman numeral in parentheses. And this is Cu2+, copper, no space, Roman numeral 2. And this font doesn't have serifs, so there's no bars at the top. We do not use the Roman numerals with the other ones. I think students would prefer that we just use Roman numerals with everything because there'd be less to remember. But it's just like that whole number one thing. We don't want to write more stuff than we have to write. And if you have to type this onto PowerPoint slides, you would understand why we don't do it unless we have to, because the parentheses and the Roman numerals is just a real pain. So we only write them for the ones that are not in group 1, 2, 3, zinc or silver. So that should become like this little chant. 1, 2, 3, zinc or silver. Those do not use Roman numerals. Everything else does. So full name for this kind of compound, you've got the name of the metal with the charge in parentheses in Roman numerals, and then you've got the name of the anion with its ending changed to I. So all we're doing here is we're throwing the Roman numerals in the middle there. Okay, so from the formula, we have to figure out what the charge is, because we can't tell from the periodic table. So let's look at this example, FeCl3. And this will be more obvious to some people than to others. But FeCl3, if we're trying to write the name for that, we first look at Fe and we see, oh, iron is a metal. Okay, so this is ionic. And then you ask yourself, is it in group 1, 2, 3, zinc or silver? No. We need Roman numerals. So its name is going to be iron, and with Roman numerals. And at this point, you can just leave a space there and say, I'm going to figure out what the Roman numeral is later. The other element is chlorine, so that would be chloride. It's kind of a sad H there. Chloride. How do we figure out the Roman numeral? It's a +3. We have to look at the anion and the ratio. So let's do this more with a picture. Here we've got Fe and we've got 3 Cls. That's what the formula tells us, FeCl3. What's the charge on chloride? Well, it's -1 because of its position on the periodic table. So if we add those up, we get a total of a -3 charge. We know that if there's -3, there must be a +3 on the other side. That +3 charge is divided among one ion. So it must be +3. So that's 3+. That's how we figure out the charge. And so then we put the Roman numeral 3 in parentheses. And that is iron 3 chloride. Iron 2 chloride would be FeCl2. Any questions?
You can do cross
Sometimes you can do an uncrisscross. Sometimes. But sometimes not. So I wouldn't necessarily recommend it. We already did that. Let's do this. Name the compound PbO. So we look at the first element, Pb. We find it in the periodic table. Okay, it's over here in group 4A, but it's to the left of the stair-step line. That's a metal. This is an ionic compound. So we name the metal ion first, and then the non-metal. So Pb is lead. Ugh. I was doing so well in remembering that. Lead. And then we ask ourselves, is lead in group 1, 2, 3, zinc or silver? No, it's in group 4A. That's not 3A. It's not a transition element, but it's not in group 3A. So we cannot predict its charge from the periodic table. It needs a Roman numeral. So we're going to leave a space here. And O is oxygen, so that's oxide. So now what we have to do is we look at these guys. We've got 1 lead and we've got 1 oxygen. We know the charge of oxygen from the periodic table. It's 2-. We have 1 of each, so the lead must be 2+. And so it's lead 2 oxide.
So in this case, I'm crisscrossing one part.
Pardon me?
In this case, I'm crisscrossing one part.
Correct. Yeah, because if you uncrisscross, then you get PB plus 1 and O minus 1. So, yeah, I generally don't recommend it. Crisscrossing, to start with, works probably about 95% of the time. Uncrisscrossing is dangerous. Any questions? Okay, this is really dumb. In fact, I'm going to change it because otherwise I'll forget to change it. Because we just did this one. Okay, that's a little more interesting. Name the compound CuS2. I'm sorry, Cu2S. Again, look at the first element. Copper, is it a metal? Yes. Is it in group 1, 2, 3, zinc or silver? No, it needs a Roman numeral. So the name of this compound is going to be copper with a Roman numeral. We don't know what it is yet. Sulfur is sulfide. So all these guys end in ide, sulfide. So now let's pull this apart. We've got 2 coppers and we've got 1 sulfur. Sulfur's charge we can get from the periodic table. It's 2 minus. So we've got a total of a 2 minus charge over here, and then we must have 2 plus over there. So we've got a 2 plus charge, and we're dividing it between 2 things. It has to be divided equally. We can't say that one's 0 and the other's plus 2. We divide it equally, and they're both plus 1. See how that works? It's a little bit like this is a mom bringing a plate of cookies. She's got 2 cookies. And so we've got 2 cookies, and this is the number of little boys. And so we have to divide the cookies equally among the little boys. How many cookies do they each get? They get 1 cookie. If we do it with cookies, you can do it no problem. So that means that your brain is very, very capable of doing the math involved here. But you get this mental block because we're talking about charges on ions, and you freak out. So if you need to think about cookies, go ahead and think about cookies. So copper 1 sulfide. Any questions? And this is part of what we'll be practicing on Thursday in lab after the exam. We'll be doing things like this. Now what if we have a polyatomic ion? Well, the names of those guys must be memorized. Do you remember those funny things I made you memorize for the memorization quiz? Here they are. Oh yeah, those guys. These are the most common polyatomic ions. And there's just not a lot of rhyme or reason to these. So here's acetate. C2H3O2 with a -1 charge. You just got to memorize it. Carbonate. This one makes a little more sense because at least this is carbon. If you notice, a lot of these have oxygen. Okay, and so carbonate is carbon with oxygen. Then you have to remember how many oxygens and what's the charge. And you just have to memorize them. Hydrogen carbonate is also called bicarbonate. This is carbonate ion with a hydrogen on it. What charge does a hydrogen ion have? Hydrogen's weird. So hydrogen's over here in group 1A with the metals, even though he's a nonmetal. If he forms an ion and he's in group 1A, what charge will he have? +1. So hydrogen carbonate is carbonate with an H plus ion on it, and so it has the charge is different than the carbonate by 1. There's hydroxide, nitrate and nitrite, chromate, dichromate, that's a weird one. Phosphate, here again with the hydrogen. Hydrogen phosphate, we're just putting a hydrogen ion on the phosphate. This one is very unusual. This is the only positive polyatomic ion that we will deal with. Ammonium. Okay, ammonium. Hypochlorite, all these guys. Again, here with sulfate, SO4 2 minus, and then we've got hydrogen sulfate. I'm sorry, hydrogen sulfite and hydrogen sulfate. So you got to be careful here. These differ by 1 letter, and their formulas differ by 1 number. Okay, so you got to be careful with those. Peroxide's weird, cyanide's kind of weird. So, yes.
You don't want us to memorize the additional polyatomic.
Well, I think after I show you this next little thing, you'll realize that you don't necessarily need to memorize the rest of them. There's a pattern that we can learn some of the others. So, oxyanions. Oxy means something to do with oxygen, and an anion is a negative ion. So these are polyatomic ions that have oxygen in them. Many of the polyatomic ions are oxyanions. And some of them make series. So you memorize the one that ends in 8. And those are the ones that were on your memorization list. Chlorate, sulfate, phosphate. And then there's a pattern. So let's look at nitrate and nitrite. What's the difference in their formulas? It's just a difference in the number of oxygens, right? This nitrite has one less. So you memorize what nitrate is. Nitrite is the light version. Like there's Bud and there's Bud Light, and it's a third fewer calories than the regular, right? But here we're talking about oxygens. So the ite is the light version. It's one less oxygen. The charges are the same. Here's sulfate and sulfite. Same pattern. The ite has one less oxygen. The charge stays the same. You see that? So then you just memorize sulfate, and you remember the pattern, which applies to all of them, and then you're good. You're good to go. So for the halogens, do you remember what group the halogens are? Group 7A, fluorine, chlorine, bromine, iodine, halogens. So those are 4 sisters. And they share a lot of things. You know, they share their clothes. Sometimes they share their boyfriends. They just, behave very similarly. So here we have a table showing what these sisters do. Fluorine, actually, she's the youngest sister, and she's a little too young to be involved in this yet. So it's mostly chlorine, bromine, and iodine. So here we've got, let's look at chlorate. So that's when you memorize ClO3 minus. Chlorite is the light version, one less oxygen. And then this hypochlorite. So this is chlorite with this prefix hypo. Where does a hypodermic needle go? Below your skin, your dermis, right? Hypo means less. So hypochlorite is even fewer oxygens than the light version. So it's one less. So hypochlorite only has one oxygen. And then going the other direction here, when we're adding an oxygen to the chlorate, we've got perchlorate. Per reminds me of the word hyperactive. Hyper, okay, means more. So perchlorate has one more oxygen than chlorate does. The charges stay the same. And this pattern works with all of the halogens. So on this table, let's back up here. On this table, we don't see bromate or iodate, do we? There's chlorite and chlorate and perchlorate and hypochlorite. But there's nothing about bromine or iodine. Bromine and iodine behave just like their sister chlorine. So chlorine forms chlorate, ClO3 minus. Bromine forms bromate, same formula, BrO3 minus. Bromite is one less, hypobromite is one less than that. Perbromate is one more. Okay, so that's a pattern. So you learn chlorate, you memorize that, you learn the pattern, you can write the names and formulas for all of these. So that's a lot of bang for your buck. Now, when you're doing the homework, the Mastering Chemistry program wants you to include the word ion in your answer. So if they give you ClO2 minus and ask you, what's the name of that? They want you to say chlorite ion. Okay, and if we have Fe3 plus, it is iron 3 ion. Sometimes we just kind of leave that off, but the program cares about it. Some of these polyatomic ions you encounter in your regular life outside of chemistry class. Sodium hypochlorite. Okay, we just learned about hypochlorite. So that is one less than the light version. Chlorate was ClO3, so this is ClO minus, and sodium is Na plus. So the formula for that is NaCl. Oh, what did I do? There we go. NaClO. Kind of a bad O. That is the active ingredient in household bleach. Kills bacteria, destroys many color-causing molecules. Sodium bicarbonate. It's one of those polyatomic ions. Sodium bicarbonate is baking soda. Okay, and you mix that with an acid like vinegar, and it makes carbon dioxide gas, and it makes things bubble. Calcium carbonate, that's found in antacids. Sodium nitrite, you may be aware that you don't want to eat too many nitrites. They're not good for you. But bacteria-filled hot dogs aren't good for you either. So it's a preservative in packaged meats. Botulism is not something you want to mess around with. A couple examples. So name these compounds. Okay, MnNO22. And when you have something in parentheses like this, remember we talked about this being a bundle pack. So we've got, when we read the formula, we just read it straight across. MnNO22. So because we're saying 2, we understand that there's parentheses there instead of saying 22. So look at the first element. Is it a metal? Yes. Manganese. We find it in the periodic table. Is it in group 1, 2, 3, zinc or silver? No. Needs a Roman numeral. So we're writing the name here, so we're going to write, did it again. Enter drawing mode first. Manganese, not to be confused with magnesium, or that mythical element, manganesium. Manganese, I'm leaving a space for the Roman numeral because I don't know what it is yet. And then I look at what's left. So, sometimes students get creative and they try to tell me this is manganese nitrogen oxide. That's 3. There are 2, okay? 2 ions, a positive ion and a negative ion. So there's a split there. So the metal is by itself, everything else is together. So that's a polyatomic ion, isn't it? And you look at that and you think, oh, that looks like that one she made us memorize. That was this one. I memorized that one. That was nitrate. But this has 1 fewer oxygen. This is the light version. That must be nitrite. So this is manganese something nitrite. We figure out the charge for the Roman numeral by looking at the charge in the anion. So this is manganese Mn something, and we've got NO2. It has the same charge as the nitrate. That's so nice. The charge doesn't change. And we didn't decide these things, right? We just discovered them and figured out that that's how they are. So some of these things we made up, like the names we made up, but the compounds and what the elements are, we didn't make them up. So what does the charge on the manganese have to be? It has to be +2. So manganese 2 nitrite. If you leave the charge off, if you leave the Roman numeral off, it's wrong. Because then we don't know which manganese nitrite you're talking about, because there's more than one.
And you got the 2 going into the parentheses?
Yes.
Okay.
So where did the 2 come from? Well, here I've got I've got nitrite, and it says there's 2 of these bundle packs, right? They each have a -1 charge, so overall they have a -2 charge. That's the total negative charge. So if that's the total negative, then the total positive charge must be equal in number but opposite in sign. I only have 1 of these positive ions. I know that from looking at the formula. So it must have the entire positive charge itself, so Mn2+. Let's name this next compound. That looks like cocoa 3. CO3. Okay, one's a small o and one's a big O. Important difference. So we have 2 things going on here. I'm going to draw a line right here. CO is 1 element. We find it on the periodic table. It's a metal. This is an ionic compound. Is cobalt in group 1, 2, 3 zinc or silver? No, it's not. So it needs a Roman numeral. Excuse me. It needs a Roman numeral. So cobalt, and I'm going to leave a space for the Roman numeral. And then what's left has 1 name. It's not carbon oxide. We memorized it. Carbonate. So CO3 is carbonate. What is the charge on carbonate? Two minus. So in this formula, I've got 1 cobalt and 1 carbonate. So the cobalt must be +2. It's not rocket science, but it's strange. And in order for it to stay in your head, you have to practice it, and that's why I give you so much homework stuff to do. You have to practice it until it sticks in your head. Did I tell you about the cow paths at Iowa State? No? Okay. So they built a new building, and they have this green lawn area. And they didn't put any sidewalks in. Like, whatever. Well, college students, we don't really care. We just walk across. So they waited like a year. And the students just walked. Well, what happens when people walk on the same grass over and over? It makes a trail. A cow path. At least that's what we call them in Iowa. It's a cow path. So after all these cow paths were established, then they come in and they put sidewalks where the cow paths are, because that's where the students are walking anyway. And so then the grass stays green because the students didn't want to walk there anyway. How smart is that? And what does that have to do with this? What, right? You're like, oh, that was a great story. Oh, wait a minute. What on earth? No, there's a reason for that. So if one student walks through the grass, does it make a permanent path? No. But if multiple students walk the same path every day, after a while the grass dies. And the earth there become very compacted. And it's going to take a long time of nobody walking there before the grass grows back. So what you're doing is you're making cow paths in your brain. So you do the problem once, and it kind of dents the grass. But, 10 minutes later, it's like, where was that? Right? You have to go over and over and over until you kill all the grass in that part of your brain. Okay? Cow paths.